Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. In our last episode, we walked through the strange 2017 discovery of Oumuamua, the first confirmed object ever detected passing through our solar system from interstellar space, shaped unlike anything else we'd ever recorded, and accelerating in a way that didn't match its visible appearance. Today, we're getting into the theories about what it actually was. And unlike most of the topics we cover in this series, the alien theory here didn't start with internet conspiracy forums. It came from a tenured Harvard astrophysicist, publishing in peer-reviewed scientific literature, making a serious structured case that deserves to be taken seriously and examined carefully. By the end of this video, you'll understand both sides of one of the most genuinely contested debates in modern astronomy. Let's start with the explanation that most astronomers currently consider the most likely. In 2020 and 2021, researchers proposed that Oumuamua might be a fragment of a Pluto-like dwarf planet from another star system, specifically composed largely of solid nitrogen ice, the same material that makes up large portions of Pluto's own icy surface here in our own solar system. This theory elegantly solves several of Oumuamua's biggest puzzles at once. Solid nitrogen ice vaporizes at a much lower temperature than the water ice found in typical comets, meaning it could produce enough thrust to explain the object's unexpected acceleration without releasing nearly as much visible gas and dust as a water ice comet would, potentially explaining why no visible tail or coma was ever detected. Additionally, researchers modeling how a nitrogen ice fragment would behave as it slowly vaporized under solar heating found that the resulting shape change could naturally produce the kind of extremely flattened, elongated profile that matched Oumuamua's observed brightness fluctuations. This explanation has gained substantial support within the broader scientific community, specifically because it accounts for multiple separate anomalies simultaneously, using known physics and known planetary materials, rather than requiring something we've never directly observed before. Like, subscribe, and hype the video. And now let's get into the theory that made this object famous in the first place. This is the theory that turned Oumuamua into a household name. Avi Loeb, the former chair of Harvard University's astronomy department, published research arguing that several of Oumuamua's observed properties were better explained by it being an artificial object, potentially a piece of alien technology, possibly even something like a light sail, a thin, reflective structure designed to be pushed along by sunlight or radiation pressure, rather than by any naturally occurring comet or asteroid. Loeb's argument centered specifically on the unexplained acceleration combined with the complete absence of any visible outgassing. He pointed out that if Oumuamua was extremely thin and flat, similar to a sail-like structure rather than a solid chunk of rock or ice, it could be significantly more affected by the gentle push of sunlight pressure than any naturally occurring object of similar mass would be, potentially explaining the unexpected acceleration without requiring any vaporizing ice at all. Loeb has continued defending and expanding on this argument in subsequent research and public statements, and importantly, he's been explicit that he's not claiming certainty. His position has consistently been that an artificial origin is a hypothesis worth seriously investigating, given the unusual data, not a confirmed conclusion. That distinction matters, because much of the public conversation around his work flattened "this is worth investigating" argument into a much more definitive "scientist proves it's aliens" headline, which isn't an accurate reflection of what he actually published. The broader scientific community's response to Loeb's theory was largely skeptical, and it's worth understanding exactly why, rather than just dismissing the disagreement as scientists being closed-minded. Critics argued that the nitrogen ice fragment theory, along with several earlier proposed natural explanations, already accounted for the observed acceleration and lack of visible outgassing reasonably well. Using physics and materials we already know exist in other solar systems, based on what we've learned studying Pluto and similar icy bodies. Many astronomers pointed to a long-standing principle in science, sometimes summarized as preferring the simplest explanation that fits the evidence, arguing that invoking an artificial, alien origin should require significantly stronger, more direct evidence before being treated as a leading hypothesis, rather than being proposed primarily because a natural explanation hadn't yet been fully nailed down at the time. Several researchers also pointed out that Oumuamua's tumbling motion, rotating somewhat chaotically, rather than maintaining a single stable orientation, seemed inconsistent with what you might expect from a deliberately engineered, controlled spacecraft, though defenders of the alien probe theory countered that a derelict, non-functional probe drifting passively through space for potentially millions of years could plausibly tumble in exactly this kind of uncontrolled way. Like, subscribe and hype the video, and let's talk about why this debate, unlike a lot of our other topics, never really got a clean resolution. Here's the detail that makes Oumuamua different from almost every other topic we've covered in this entire series. There's no possibility of gathering additional direct evidence. The object is gone, permanently exiting our solar system, far too distant and far too faint for any current telescope to study further, and no spacecraft was ever positioned to intercept it during its brief visit. This means every theory about Oumuamua, whether it's the nitrogen ice fragment explanation or Loeb's artificial probe hypothesis, has to be evaluated using only the limited handful of months of distant ground-based data collected back in 2017 and early 2018. Unlike the WOW signal, where modern telescopes can at least keep checking the same patch of sky for a repeat occurrence, Oumuamua physically cannot be re-observed, studied further, or directly investigated again using any currently available method. Some researchers have proposed designing future spacecraft capable of rapidly intercepting the next interstellar object detected entering our solar system, specifically motivated by the missed opportunity Oumuamua represented. If or when the next one is detected, having a spacecraft ready to actually fly close enough to capture detailed images or direct measurements could finally settle questions like these with real data, rather than distant brightness measurements and trajectory calculations alone. So here's where this debate genuinely stands today. The nitrogen ice fragment theory currently holds the strongest support within the broader scientific community, because it explains multiple separate anomalies using known physics and materials we've already confirmed exist elsewhere. Avi Loeb's artificial probe hypothesis remains a minority position, but it's a scientifically published, seriously argued minority position from a credentialed researcher, not a fringe internet theory, and he continues to argue that the possibility shouldn't be dismissed without stronger natural evidence to fully close the case. What makes this case genuinely unusual, even among everything we've covered in this series, is that reasonable, qualified scientists looked at the exact same limited data set and reached meaningfully different conclusions about how seriously to weigh an artificial explanation. And because Oumuamua is now permanently gone, that disagreement may never get fully resolved one way or the other. So that's Oumuamua, the first confirmed visitor from another star system, shaped unlike anything we'd ever recorded, accelerating in a way that still doesn't have a universally agreed upon explanation, and now permanently gone, somewhere out past the edge of our solar system, continuing on a journey that may have started millions or even billions of years ago, long before it ever crossed paths with us at all. If you've made it through both episodes, let me know in the comments which theory you find more convincing. Like, subscribe, and hype the video, and I'll see you in the next one.